Hello grade 6, how are you doing? This is Miss Susan. Today we will learn together about the topic Describe Distributions, lesson 13.7. Our essential question is,
how can you describe the distribution of a data set collected to answer a statistical question?
So we will have two main duties. The first duty is to describe the distribution of any data set. So we will have a graph, or we will have a group of data set, and we will need to describe the distribution of this data and to be prepared to answer a statistical question. So we will take some statistical questions about the graph, and our job is to answer these statisticals. Okay, so let's see together how we can do that.
Here's a problem that asks you to graph a data set to answer a statistical question.
So first we need to graph a data by using this table, the frequency
Let's
table.
unlock the problem.
And the best graph to describe frequency data, or the frequency of data, is using the line plot. So let's graph the data first to answer some statistical questions. So let's read together what is the example.
Hector asked 20 of his classmates how many pets they have. The table shows the results of the survey. Graph the data set to see the center, spread, and overall shape of the data. List some statistical questions he could use this data to answer, and then answer them.
Okay, so the givings is the table. He jotted down the survey about pet. These are the number of pets, and that's it, the frequency of how many students have these numbers of pets. So let's graph together line plot. We will put on the line number 0, 1, 2, 3, 4, and then we will plot how many students have this amount of pets. So let's unlock the question together to graph the line plot.
First, let's decide how to display the data. There are too few values to make a meaningful histogram, so let's make a dot plot. Use the same title as the title in the table, Pet Survey. The horizontal axis represents the number of pets. The dots will represent the number of people with that many pets. How many students in the survey had no pets?
So how many students have no pets? 2. So let's plot 2 dots.
There are 2 students who have no pets, so show 2 dots over 0 in the dot plot. How many students have 1 pet?
6 students have 1 pet.
6 students have 1 pet, so show 6 dots over 1 in the dot plot. Show 7 dots over 2 in the dot plot. How many dots do you show over 3?
3 students have 3 pets.
3 dots. And 2 dots over 4. Now, let's look at the overall distribution of the data. Are there any gaps in the graph?
Now let's interpret the data. Okay, if this graph contains any gap, and we said gap is the intervals that not contain any data, that doesn't contain any data. So do we have here any interval that doesn't have any data? No, sir. So there are no gaps in this graph.
No, there are no gaps in the graph. Are there any peaks in the graph?
The peak is the highest column in the graph. So where is the highest column here in the graph? Over 2. Yes, there is a peak.
Yes, the graph peaks when the number of pets is equal to 2. Now that we have a graph, let's ask statistical questions about the data. A statistical question is one that asks about a value that describes a set of data. For instance, how many pets do the greatest number of students have?
The greatest number of students have 2 pets.
The greatest number of students have 2 pets. Another statistical question is, how many students have 4 pets?
So 4 pets. There are 2 students have 4 pets.
4 is the greatest number of pets, and there are 2 students who have 4 pets.
Is it easy to answer statistical question? If you can interpret your graph properly, so you can answer any statistical question easily. So let's move to another example.
Let's answer some statistical questions using a box plot.
First, let's read the question together.
Hector asked 20 of his classmates how many pets they have. Use the box plot to describe the distribution of the data. Then list some statistical questions Hector could use the data to answer. Let's unlock the problem.
From the box plot, we can know the median, the lower quartile, the upper quartile, and the greatest point, the least point, and the range between them, and the interquartile range inside the plot, right? So let's unlock to interpret our data.
First, let's look at the distribution of the data. Use the box plot to find the median.
Where is the median? Just in the middle of the box, right? So it is over 2.
The box plot shows that the median is 2. Now find the range of the data.
The range is the difference between the greatest point and the least point. So the greatest point here is 4 and the least is 0. So 4 minus 0 will be 4.
The greatest value is 4 and the least value is 0. 4 minus 0 is 4. So the range is 4. What's the lower quartile?
The lower quartile is here at the beginning of the box, the right of the box. It's 1.
The box plot shows that the lower quartile is 1. Now find the upper quartile.
Okay, it's on the left side of the box. It's between 2 and 3, so it is just in the middle. 2.5 will be.
The box plot shows that the upper quartile is 2 5/10. Since you know the quartiles, find the interquartile range. What's the difference between the upper and lower quartiles?
To find the interquartile range, you have to find the difference between upper quartile and lower quartile. So 2.5 minus 1 would be 1.5.
The interquartile range is 1 5/10. Let's see what statistical questions Hector can use the box plot to answer. Can Hector use the box plot to find the least number of pets?
Yes, the least number of pets is the least number here is 0.
Yes, the box plot shows that the least number of pets is 0. Can you use the box plot to find the number of students with this many pets?
Number of students with 0 pets. No, it's not shown here because this graph is not describing the frequency of data. It's describing only the average of data and the change in data or the variety in data. So no, I can't know because this graph is not showing the frequency.
No, you cannot find the number of students with 0 pets because the box plot does not show the frequency. Let's look at the distribution of some data and find statistical questions.
Let's read the question first.
Connie asked people their ages as they entered the food court at the mall. She arranged the data she collected in a histogram. Describe the distribution of the data. What statistical question could Connie answer using her data? Let's look at the distribution of the data. How many peaks are there?
So,
Type to complete the answer and then check your work.
to know that histogram also can describe the frequency of data. Okay, so line plot, frequency, line plot and frequency table and histogram can describe the frequency in data. However, box plot is not describing the frequency of table. Okay, so first find the peak. The peak is the highest column here. Actually, we have 2 columns are the same length. So I have 2 peaks.
Excellent. There are 2 peaks in the data. Where is the leftmost peak? Click the correct column in the graph.
The left peak is here, between 11
Great
and
job.
20 years.
The leftmost peak is at ages 11 to 20. Where is the rightmost peak?
The other peak here, to the right, it's between 61 and 70 years old.
Great job. The rightmost peak is at ages 61 to 70. So the 2 peaks are at ages 11 to 20 and at ages 61 to 70. Now, let's figure out how many gaps there are.
The gaps is the intervals that don't contain any data or any information. So here, this interval doesn't have any data. So I have only 1 gap.
That's right. There's 1 gap in the data. Where's the gap?
It's just here.
Great job. The gap is at ages 51 to 60. There are many statistical questions Connie could ask about her data. Can you think of one and type it into the box?
Yes, I can think about, for example, how many people from ages 41 to 50 visit the food court. Question mark. Next.
Connie could ask what age groups are most likely to eat at the food court, or what age groups are least likely to eat at the food court.
So let's answer these questions. What age groups are most likely? Most likely mean the highest number. So most likely are from ages 11 to 20 and 61 to 70. What age groups are least likely to eat at the food court? The least likely are the least or the shortest column here. It's from age 41 to 50. Okay, why it's not 50 to 60? Because no one visit from this age. So
now try your homework on your own with the personal math trainer. It includes the exercise you saw at the beginning of the lesson.
Thank you, grade 6, for watching. Hope that you all understood this lesson properly. Please practice at home.
Thanks
See
for
you
helping me
next
determine
Sunday.
which question the scientists could ask about the distribution of their data. See you soon.
Bye.